All right, well, appreciate again all of you guys calling in. So I think this is the first time that I have interfaced with a lot of the forecasting community. So I'll go ahead and give a quick introduction. My name's Josh Willis. I have been with the Corps of Engineers for about a little over 4 years now. Been working under Matt Fleming at HEC in the Hydrology and Statistics Division since about February. So still kind of new to HEC. Before that, I worked at the Fort Worth District in the Water Resources Branch Study Section. I was there for a couple of years, and I actually started out in the Galveston District as a project engineer, mainly administering dredging contracts. So I've bounced around a little bit within my 4 years with the Corps, but I've gotten to work with some really great, smart people, and very happy with the way things are turning out. So with that being said, we'll go ahead and get started. So from what I understand, it's been, I think since January, since HEC has kind of last interfaced with the forecasting community. And so since then, we have implemented several new features into HMS that we kind of wanted to showcase and demo for you guys today, just so that you're aware of all the new stuff that's going into HMS. So we'll do a few live demos, and then after that, Simeon Benson from the Fort Worth District is going to highlight some really interesting forecasting that he got a chance to do at Sam Rayburn earlier this year back in May. And without stealing too much of Simeon's thunder, for those that don't know, so Sam Rayburn's a large reservoir in southeast Texas. And what's really unique about this reservoir is the emergency spillway that you can kind of see in the left part of the graphic here. So this emergency spillway has a labyrinth design. And from what I understand, this is actually the first spillway of its type that the Corps constructed. Back in, I think this started back in the mid-1950s. So I'm not sure how many spillways there are like this today within the Corps' network, but this was the first. So if you don't learn anything else from this meeting, hopefully you can rest your hat on that interesting tidbit there. So after that, we're going to get into some of the future plans that we have for enhancements into HMS that we think are at least somewhat related to forecasting, and then open it up at the end for any sort of discussion or questions that you all might have. So before we get started with the demo here, I would like to mention, so each of these four items that we're going to be demoing today, these are only available within version 4.9. And so just to kind of highlight where you can get that from, if you go to our main documentation page, and these links should all be included within the slide deck. I believe that's attached to the calendar invite. So if you go to downloads, you have access to the latest beta of version 4.9. So you don't need any admin rights to get this installed on your computer. You can simply download it and unzip the folder on your local computer. And so also all of these features that we're going to be covering are documented within the version 4.9 release notes as well. So there's that. All right, so with that, looks like we got Tom on. Tom is going to show off the new automated forecasting tool. So Tom, I'll go ahead and turn things over to you. Not getting any audio, Tom, or at least I'm not.
Okay, mute button.
There we go.
Got me. I was just raring to go. All right, automated forecast. So the automated forecast is just a tool that allows you to run a forecast in a really short amount of time. It uses data feeds that are out publicly available. And so I'll just demonstrate that. when I give this demonstration, I usually try and figure out an area of the country that has a decent amount of precip, just so it's an interesting forecast and it's not, you know, zero precip for the next 21 days like we often get in California. So it actually turns out that California is getting precipitation today, and I do have a model of the East Fork of the Russian River here, so I'll do that demonstration for fun. So for those that don't know, the East Fork of the Russian is somewhere in this area of the country, Northern California, just on the edge of the green. Maybe I should have gone with the Punxsutawney model today. It's a little more interesting over there. But, so East Fork of the Russian, Northern California, I'll just zoom in, and what we'll be doing is forecasting inflows into this reservoir, which is Lake Mendocino. So I want to say the gauge is somewhere in this area coming off of the East Fork of the Russian River. And so with that, what I'll do is I'll walk through what this looks like in HMS. The only requirements for this automated forecast is just that you have a spatially aware basin model. I say that now, I might think of some other requirements as I go through it, but it is important to have a spatially aware basin model because we are taking gridded precipitation data and rectifying it over some polygon. So if your basin wasn't spatially aware, we wouldn't know where to extract precipitation and temperature information from the gridded data. Okay, so with that preface, I'm going to go to the Forecast Alternative Manager, and the button is called the Auto Forecast, and it's to create a forecast alternative with automated data retrieval. It's a 4-step wizard. On the first step, I give the name of the automated forecast, and it defaults to a name that is roughly the time that you accessed this wizard. So I'll just use that default name and continue. Then I select a basin model. I have my East Fork Russian River basin model. I'm going to continue with that. And now I get into some of the more interesting stuff. So I'm asked to specify information for a look-back period and the duration of the look-back period. To keep things pretty quick, I'm just going to use a look-back period of 7 days. I can go all the way up to 30 days if I wanted to. I believe the RTMA data goes back 30 days. And then I have to select a data source. Right now, there's one look-back data source, and that is RTMA, Real-Time Mesoscale Analysis. And now I'm asked about some forecasting products. So there's options here for high-resolution rapid refresh, North American Mesoscale Model, and Global Forecasting System. I'm just going to use HER and NAM today, and I'm going to go ahead and kick off the automated forecast. So right now what HMS is doing is it's using web calls to reach out to servers on the web to pull in data. And so I'm using these Threads data servers from UCAR. And if you poke around a little bit on the server, you can get an idea for the kinds of data sets that are available there. So we're importing, let's see, this is forecasted data. So I'm pointing to, I can go into HER and I can get the latest forecast data. So I'm actually, the queries are just based off of this. This is just a web interface for the data server. And so you can see the types of variables that I can query. I can also do spatial, set spatial extents. So I don't have to import for the entire nation. I can just import for the area that I need. And I can import from a variety of different forecasting products. So right now, I just used HER and I used North American Mesoscale. And what HMS will do is it will layer those together with the priority is the highest resolution. So HER data is higher resolution than North American Mesoscale. So if there is a conflict, an area that conflicts temporally, the HER data would take precedence there. And then HMS stitches together the hindcast period and the forecast period into one continuous simulation. So that's what you just saw. It actually pulled the data in. It's going to come down in NetCDF format. It converts it to DSS for the HMS run, and then it runs the simulation. So it did all of that in just a few minutes, a minute or two there. So let's take a look. So I just did a little bit of calibrating to the model before. This model was calibrated for events that were closer to 18 or 20,000, but you'll probably normalize on the type of calibration for the types of events that you're experiencing here. So that's just kind of like a first cut run, and I'd probably do some more calibrating. In the event that I might have a peak occurring on the 11th, I'd want to try and dial this calibration in a little bit more so I could have more confidence on what might happen in the future. But that's all to show you that the whole forecast can happen in a matter of minutes. And I really had in mind kind of the emergency response scenario with this tool, because I know in a lot of cases in emergency response, time is of the essence and data feeds are up and down and difficult. And so I really wanted to give folks a tool in the midst of emergency to really rapidly generate forecasts. And so I think this tool accomplishes that. It's really just the implementation wasn't too difficult. If you all had followed the Vortex utilities and what's happening with those over the past couple of years, this was just welding a few of those pieces together to get this product. So that's all it really is. All right, I guess I'm handing back over to the MC, Josh.
All right, thanks, Tom. Yeah, so this is the second time I've seen Tom demo this new automated forecasting feature, and it still just blows my mind how quick and seamless it is to get a forecast up and running. Before we move on to the next couple of demos, are there any questions from the field regarding the automated forecast tool that Tom just demoed?
I have one.
Go ahead.
So, hey, so how easy is it to set up those data feeds? I guess is that something you kind of do ahead of time? Like if we had a list of data feeds we use frequently, we could kind of set that up.
So right now they're kind of, well, they're not necessarily, there's no setup right now. It's a little bit hardwired. There is a properties file where you can change like the URL to the different data feeds you want. So these are national scale products. So I kind of assumed for the nation what people might want. But you saw, like, for the look back period, I just had one option, and for the forecasting period, I had 3 options. And so the idea is that I could start building those out. If people start using this tool and finding it helpful, but maybe you have a regional product, then I can help, wire in the new data feed. But other than that, it's just these national products. Obviously, it probably wouldn't work in Alaska. It'll work in CONUS because these are CONUS-based products. But yeah, if there's interest, and if you all want to peruse the Threads data servers and you find different feeds, or a feed from another server, say, I think in the future we would like to connect with Cumulus, we can wire in those data feeds.
So what all data sources are you connecting to? What different data?
So right now, for the look back, I'm using RTMA. There is an MRMS data feed for precipitation I could tap into. And then for the forecasting period, I'm using HER from 0 to 18 hours. And I believe that's I think I'm using hourly, 0 to 18. And then North American MESO scale from 0 to 3.5 days. And I want to say that's hourly as well. And then there's an option to go out to 16 days with GFS. The resolution gets a little bit larger. Yeah, I think that's it goes to like 6 or 12 hours towards the end of the GFS, the 16-day GFS period. So those are the data. Those are the
GFS. That's forecasted rainfall.
Yeah, GFS, 16 days out. There is actually, for some of the folks in snowmelt areas, there's some climate. It's actually called CFS, Climate Forecasting System, and that goes out, I want to say 9 months, and it's climate-based data. There's a certain amount of faith you put in that. It starts to tend towards climate normals over time, but that's out there as well. We could potentially add that in.
Is this version of HMS available in tools like SWIMS and RTS? And will it be?
If it's not already, it's working in that direction. We have our team member, Alex, I don't know if he's on the call, but he's our SWIMS integration person, and I know he's been testing 4.9 and the CABI.
The next version of SWIMS is going to release with version 4.8, but it's a 15-second job to swap in 4.9. Subsequent versions of SWIMS will go out with 4.9.
All right. Great questions. Thanks for that, Tom. I will go ahead and steal the presentation back here from you. Okay, so these the next two features I'm going to go ahead and demo, and they're not quite as flashy as the automated forecast tool, but I think they're really going to be helpful in kind of keeping things organized. So I'll go ahead and first off, I'm going to show off the global file reference table, and then I'll follow it up with the DSS grid record validator. All right, so I have, I guess first for some context here, what I did was I just went onto a server and I downloaded a project onto my local C drive here, extracted the project, and now I'm going to open it up in HMS for the first time. Let me expand this out. Okay, and as soon as I opened up HMS, I got a pop-up here with missing file references. And so it's the first time, if there is a data connection where the file is missing, this table will pop up right off the bat, and it's set to just show the invalid references. But I'll go ahead and turn off the filter here, and you can see that this table lists all of the references within the project. And this first, this SWIMS grid data is the file is missing for that. And so I don't even have a D drive on my computer, but I do know where this file lives, so I can go ahead and navigate over to that. So it shows up in red because it's missing. And then I'll go and I'll select it here, save, and then apply. And notice now that it shows up in orange. And so with this orange color, what it means is that the file exists, it knows where it is, but it's located external to the project. So if this, if I was working on this for real, it's usually a good rule of thumb to try to have all of your file references internal to the project if you can, using this data folder that's provided. Okay. So this is really handy because I'm sure that we've all been in this scenario where we've opened up a model that we've received from somewhere else or from someone else. And before you'd get all of these dialogues that would pop up for each of the missing files. And if you didn't restore those links at that time and you X'd out of those dialogues, I believe, and I guess, Tom, you can correct me if I'm wrong, or anyone, I guess, but I believe that the reference to that path would be lost and would automatically default to whatever the project DSS file is, which can lead to a lot of confusion. So now you get this nice, helpful dialogue that kind of summarizes if there are any missing files or if the files are located external to the project. And this color convention too has been carried over beyond this table, and you can actually get it within the Watershed Explorer as well. So I'll go to that file that was missing that I reestablished the path to, and you can see that it shows up in the orange color. Again, meaning that the file exists, but it's external to the project. And if you were to open up HMS and there weren't any files missing, but you still wanted to look at that table, you can access it via File, References, and it'll pull that table back up. So kind of a simple tool, but very powerful and very helpful in keeping things organized. Secondly, I wanted to show off the DSS record validator, the grid record validator. And so I'm within the Watershed Explorer here. I'm looking at my precipitation grid sets. And you can access this validator by right-clicking on the grid set and then clicking Validate. And what this does is it scans your grid to make sure that it's valid. And so this is a good check here. As forecasters, you're obviously working with a lot of different types of gridded data. It's easy for those gridded files to kind of get corrupted or get off kilter, and this is a quick way to kind of analyze that. I'll go ahead and click on the second one here, run the validate tool, and it looks like something's wrong with this one. So if you look at this, it gives you a nice little error, and it says that the lower left corner changes, and then it gives you the path name to where this occurs. And so when you're dealing with gridded data types, usually it's important that that corner location remains the same for each of the grids representing each of the time steps. That grid is what's tied essentially to a coordinate reference system, and so you don't want that changing. So this it gives you the error, and it tells you exactly where it's occurring, so you could go in and take a look at that. So I'm going to open up DSS View here. I'm going to go to that file. Let's see, Tropical Storm Hermine. Here we go. And I'm just going to visualize the first 5 here for time's sake. It's telling me that these changes are occurring September the 2nd from 1 to 2. So I've selected that. Go ahead and plot it up. And this might be hard for you guys to see, but I'm going to start at the end and kind of scroll backwards. And you'll notice that this lower left cell is negative 163,334. That's staying the same. That's good. The grid extents, kind of the number of rows and columns, that's staying the same. That's also important. And then I get to the very first one, and those changes. And so any type of compute that you were doing that was tied to this precipitation data set would not run. But you get this nice dialogue that kind of shows you what the problem is and where to go to fix it. So again, simple tool, but can be very powerful in helping you to diagnose where there are problems. And before we move on to the last demo, are there any questions regarding either the global file reference table or the grid validator? All right. Well, with that, I think the last demo here that we'd like to show off is Spatial Results. And so Nick Fan, Mike Bartles, Tom Brower, they've all really added a lot of cool little features to the Spatial Results framework, not only in 4.9, but also in other recent versions as well. And so I'm going to turn things over to Mike Bartles, and he's going to touch on some of these new features.
Thanks, Josh. All right, so I want to talk, like Josh said, about spatial results. I also want to frame it in the context of how most HMS models that were built as part of SWIM's implementations would function, but then I want to show a couple of other features that you'll get if you do upgrade to newer ways of dealing with gridded information. So if you've used HMS post 4.7, you notice that we went to discretizations. No longer do we have grid regions. We banished grid regions to the basement. Don't deal with those anymore. Discretizations make things a whole lot easier to deal with. The 99% use case for HMS models that were part of SWIM's implementations are file-specified discretizations. And that entails linking to a .mod file, right? Those used to be created by GeoHMS. We can now create them within HMS like 1.5 million times faster. If you actually go through it, you would click on Create Grid Cell File, and you can output what that is. So you can still deal with it that way. It does come with a couple of limitations, though, when it comes to spatial results. So I've computed my simulation, my forecast alternative, or my forecast variant, actually, in this case. This one does have future precipitation, and I get my drop-down of spatial results that are available, given the options that I have selected as part of that forecast alternative. So if I included snowmelt, I would have additional ones here. I'll show you an example of that in a minute, but all simulations, no matter what, will have precip loss and excess as a bare minimum to deal with. But if I have cumulative selected and I click play, I can roll through how precipitation actually fell throughout the simulation, throughout my individual subbasins. Notice that the colors are changing subbasin by subbasin, right? We're not visualizing individual grid cells. That's because we're using file-specified discretizations in this case. Every single subbasin here is using the .mod file that I created. And that has some limitations to it. We know essentially the index of where the cells are, we just don't know their spatial location. So we're really relying upon, you know, every single cell to have the exact same index location, so on and so forth. That makes it really fast, but it loses some of that spatial connection. And the best that we can do for spatial results in that case is to give you a sub-basin average. However, you can still visualize it that way. The things that we've added most recently to enhance the use of spatial results are tooltips. So if I have a valid spatial result selected, and I go to a specific time step and hover over any location that actually does have results, I'll get a tooltip along with the units that go with that. So you move it, that gives you the different results. Notice that these things don't change per sub-basin, right? Because I only have one spatial result essentially for the entire sub-basin, since I'm using a file specified discretization. If I go out here, outside of the realms of where I actually have valid spatial results, I go back to the tooltip that gives me my XY position. But if I come in here, go back to the tooltip, I get that. That's not the only thing that we got. So you can also right click in here and say plot spatial results, and that'll bring up a time series of the actual values. Again, I'm plotting cumulative precipitation. The plot spatial results option will give you a plot for the entire simulation time window. So our forecast time period, I think was, or the forecast was like the 13th or 14th in this case. I forget what the specific date was, but that's essentially when all this precip fell. Right before that, we have a little bit in the forecast period, but it helps to visualize those things. You control spatial results again, in case you haven't dealt with them before. If you go to the compute menu and choose your simulation run, forecast alternative, what have you, go to daily summer in this case, and go down to the bottom. And this will be toggled to no by default, but if you want them on, go ahead and change that to yes. And now I can output spatial results at any time step equal to or greater than the simulation time step. So in this case, I'm computing at a 1 hour interval. I can compute or I can output spatial results at a minimum of 1 hour all the way up to 1 day if I wanted to accumulate that. Now, if you do use different options than a file specified discretization, you get a bit more to deal with and a bit more information to go with here. So in this case, I have another basin model that's using the structured discretizations. Similar concepts. In this case, I'm using the SHG projection and 2,000 meter cell size, but now each one of these individual cells knows where it is in the world. It has a defined XY, not just an index location, but a defined actual coordinate reference system and a known XY that goes along with that. The cool thing that I get out of that is then I get individual cell results, right? So this is plotting melt rate ATI. This simulation actually includes snow melt, so you get an additional length of variables. We still have precip, loss, and excess, but now I get additional spatial variables that are tied to temperature index snowmelt, SWE, cold content ATI, liquid water content, melt rate, so on and so forth. We have additional alternatives or additional methods that come along with additional variables as you go through here, but I can also visualize those. But notice that each one of those cells are changing. So I get to visualize not just, you know, a sub-basin average, but I get to visualize specific cells of interest, right? So if I go back to one that or a time step that I'm really interested in, so I got a whole bunch of snowmelt that's going on here, I can hover over the cells of interest and I get their values. So this cell is 0.66 degree Fahrenheit days. This one's 0.33, this one's 0.03, this one's 0.33, so on and so forth. Each individual cell, you can visualize the results. Same thing applies here. If I want to visualize the entire simulation time window, I can right click in that cell, click plot spatial results, and now I get a plot of the actual melt rate ATI. This is for that cell. Notice in the legend, we highlight, hey, here's the grid cell that we're specifically looking at. We left this as a breadcrumb in case we ever want to come back and figure out what may be going wrong in the tech support or anything like that, but you can easily identify where that's gone. In the future, we'd like to highlight that cell, maybe outline it in pink or something like that for you to actually see what's going on there. So those are the spatial results, visualization enhancements. Oh, one other thing, I forgot to mention that. Cogwheel, click on the cogwheel to bring up the visualization before. This editor used to be something that I shied away from because it was hard to explain how everything works. Nick Van has done an amazing job on making this thing better. Now it's intuitive how these things should actually function, right? So if I click on that cogwheel, I get to choose, you know, how I have individual tabs so I can speed up or slow down the animation if I want to. But on the symbology tab, this is where the real magic happens. I can choose the way in which we're going to visualize this color palette, or what color palette we're actually going to apply, or the scale that we're actually going to use to visualize those things. So if I wanted to change that visualization scheme to, I don't know, let's do 10-degree Fahrenheit days. Now I can apply that. Now every individual cell that's 10 or above would get this color. 0 gets this color, in between gets all the way up here. If I wanted to visualize values that are higher than that, maybe I wanted to say, okay, give me this color palette between 0 and 10-degree Fahrenheit days, but if anything is above that, I want to highlight that. So I'm going to toggle on this above max color, click this button, and now I want to make them pink, something like that, to stand out. I can do the same thing for below minimum value, and I can also do the same thing for no data colors as well. You get different options in here. You can do stretch or classify. For specific variables of interest, let me go back to this one real quick and highlight this. Like precipitation, we had additional methods in here for you to choose from. These are essentially like unique color palettes that are for that. Most people like to visualize precipitation using the National Weather Service radar palette that has defined colors and values. So when you see blue, that means, hey, it's 0.01 to 0.02 inches in here. But you can change this however you would like to see it. Hopefully this is a little bit easier to navigate than those past editors. But consider that past one was an initial rollout of these features. But like I said, Nick has done an amazing job making this better and much more useful. Anybody have any questions on spatial results enhancements? All right. I'm always open for suggestions as well. We have a whole lot of other stuff that's coming in, like legends and scales and things like that that you can visualize within the map. So sky's the limit on this stuff. If you guys do have any suggestions, please send them our way. I'd love to hear it.
Mike, I would say like a legend and a scale and a little north arrow. Seems dumb,
Yeah,
but
oh, no.
well, all it would do is let me screenshot it and put it in a report, because a lot of times we like to have a legend, a scale, a north arrow, and a lot of times I have to go to GIS to do that, and then I'm busy trying to make GIS look as nice as HMS does. So just having a few simple things like that would help our reporting processes, I think.
Yep, 100%. They're in progress right now. Look for those within 410. We'll have those out in the next release.
Good.
All right, so the next thing I wanted to talk about are some future things on the docket that we plan on implementing in HMS. And some of these I think are kind of tied to the scenario that Simeon just presented to us. So first of all, time varying parameters. So this has been kind of in the discussion for a little while now, and we've had a user interface design in place, but the model code framework to implement this has been kind of lacking. And so there's still some uncertainty with funding for this effort, but the plan right now is for us to work on the model code to where you would be able to specify a parameter value, such as a constant loss rate, at each time step within a time series or an annual pattern. And so the plan this FY is to try to get that model code in place, the code that you don't see that happens behind the scenes, and then have kind of one simple implementation of that, which you can see in this component editor over here to the right, to where you can essentially specify, your time series or your annual pattern on how you want certain parameters to change over time. So this is exciting stuff. Again, there's some uncertainty here, but this is currently the plan. And then I also wanted to mention storm shifting. Really, the emphasis behind the storm shifting that we plan to get incorporated into HMS this FY has to do more with stochastic storm transposition. So as a foundation for SST, you essentially want to be able to sample from gridded storms within HMS and then be able to kind of randomly move them throughout your subbasin. But as sort of a byproduct of this, we also plan on tying the ability to shift storms in HMS to an optimization framework. And so the scenario that Simeon just described, where headquarters was essentially asking him to take the QPF and then shift it over the basin, I think that this could potentially, the storm shifting optimization could potentially apply to or be useful for forecasting as well if you want to find the worst case scenario. So essentially, what this would allow you to do is to take a precipitation grid that happens, within or near your watershed of interest, and then move it throughout the basin and compute. And you could essentially set it up to where you could find the location of the storm that would lead to, let's say, the max pool elevation at a reservoir, to kind of, again, paint that sort of worst case scenario. What could happen if this QPF shifted a little bit and hit, sort of the worst possible spot. So this is some exciting stuff that we at HEC are very excited about, and we think that there are going to be a lot of uses for this out in the field as well. And then lastly, I wanted to mention the role-based reservoir operations. So this is going to be pretty simple. Nothing as complicated as something that you could do in ResSim, but we do plan to implement the ability, to specify a downstream control point and then set some sort of threshold. And so this, could potentially, be beneficial for forecasting, at least, simple scenarios. So just wanted to kind of whet your appetite with these things. And then last but not least, we do have some relatively new documentation out on our website that we wanted to bring your attention to. So this first link here is a tutorial and guide that Matt Fleming put together on using save states within a forecast alternative. And so this is on using save states to initialize snowmelt parameters. And, me growing up in the Southeast, snow is kind of an abstract idea to me. But essentially what this gets at, as if you're forecasting, let's say you need to make a snowmelt forecast or a rain on snow forecast, and you need to start that, when a snowpack already exists. Well, that makes it really hard to initialize your temperature index state parameters. And so oftentimes it's easier to start, your forecast before the snowpack exists, let's say in like October, for example. And then once you get to the time frame where you actually want to start your forecast, then you can use save states to sort of compute your temperature index state parameters. I hope I said that correctly. Don't hold it against me if I didn't, but this is a really neat tutorial and guide. And we are actually actively looking for people from the district to also put together some tutorial and guides for forecasting as well. So all this really is, you give kind of an introduction, you set up the scenario, some screenshots, and you have a model that you can download and just kind of outline the steps that you take. And so within the let me pull the presentation back up here. We have some topics here for future tutorial and guides related to forecasting. So if any of these pique your interest, please feel free to reach out to me directly. We have funding that we can get to you guys pretty easily to work on this. And this list is not an exhaustive list. If you have any ideas on something that you think might be helpful to put in a tutorial and guide for other people to use, please, by all means, bring it to our attention. And then I also wanted to mention this forecasting case study. I believe Mike Bartles and Tom Brower worked on this. This is sort of a case study flood forecasting guide for the Kaskaskia watershed. And it's really good kind of start to finish, you know, creating the model, calibrating it, actually running the forecast, just provides a good overview of that whole process. And it's something that I think is particularly useful for someone who might not, you know, like myself, who might not be as familiar with forecasting. It kind of covers everything from top to bottom there. All right, so we have about 5 minutes left. Are there any questions or any comments from anybody?